Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will continue to discuss our our discussion on how to design a pavement using H2 method. Now, the third parameter and the important parameter for flexible pavement design is the traffic. Now, you can understand why it is very important to know the amount of traffic load that is being experienced by our roads. Actually, all these vehicles are not loaded, but they are very overloaded, and that's why our pavement fails prematurely. So, what we can do is to try to estimate this road as accurately as it could be. So, what are the issues on while knowing the traffic? The traffic on the road is composed of application of axle loads of various weights and configuration. The weight ranges from less than 2,000 pounds on a single axle to more than 50,000 pounds on multiple axles. Equally important is the local knowledge of the roadway, as you have seen in the previous slide. Now, in order to determine the load effect on pavement during a particular design period, the designer must determine the weight distribution of various axle configurations, should be aware of the type of vehicle that will ultimately be used on the roadway. Under ideal condition, should perform field traffic counts to determine the AADT. I can understand this word is not known to you. A means average, second A means annual, D means daily, and T means traffic. What we do is we count the traffic each day, 24 hours a 24 hours a day, 7 days a week, 365 a year, and we accumulate them, and then you divide it by 360 to get average annual daily traffic. The word traffic means different vehicles. It can be a car, can be a motorcycle, it can be a truck, it can be a bus or any other vehicle that are using your road condition. But mind you, for design of pavement, we only interested in a vehicle that has got at least 6 wheels. So by this, I mean that the cars and the other motorcycles or any other vehicle that has got 4 wheels are generally ignored in pavement design of highways. Now, what is needed to be estimated? Increase axle loads, higher tire pressures, very high traffic volume. Traffic volume means number of traffics, and the new axle configuration. Actually, these new axle configuration is coming because of to accommodate higher load on the vehicle without compromising the without compromising the the weight the weight characteristics of the vehicle. Now, how we do this volume count? First, as I said, we count total single unit trucks multiple units, that I mean tractors, and other class of vehicle. The time of the day of the week, and seasonal variation. Now, since we are interested in trucks, so we say if you have an ADT of say 1000, it means at least there are 150 trucks or 500 trucks. So that's up to 50%. Now, what are the traffic related variables? Axle load magnitude, axle configuration, number of load repetitions, growth rate, lane distribution, tire pressure. This information is required to determine the structural requirement of the pavement for both new construction and for rehabilitation design. So what are the axle types? Axle means a member, horizontal member that support tires. So we have single axle with single tire. A car has two single axle and each of them have got two tires. Since the car has four tires, that we say two single axle with single tires. There is a single axle and then it is supported by dual tire, like tires you have seen in the bus or a truck, in which on the front axle there is a single tire with single axle, and on the rear axle there are dual tire on a single axle. Now, if the axles are together, one after the other, if you see two wheels together, then that is called a tandem axle. And it can happen that a tandem axle can have a single tire on each of them. There can be four tires on tandem axle, but practically we have two tires each on each axle, means a tandem axle generally had 8 tires. Then we have a tridem axle. This tridem axle has 12 tires, and actually if you can estimate, there are 12 tires on a tridem axle vehicle. Let me explain you more about this axle types. This is the pictorial of truck types that are usually used in Pakistan, that are on the roads of Pakistan. This is a two-axle single Bedford truck. What I can say is that there is a single axle here having one tire each, and then there is a single axle at the rear. This is called a single axle with two tires. So if the truck has got 6 tires, the allowable weight is 17.5 tons. Then there is another wake of vehicle that we call Hino Nissan, and it has the same configuration. Now, there is one thing more. The axle, this axle is known as steering axle, and this is known as a drive axle. So, this truck has got single axle on the steering axle and a single axle on the drive axle. Now, this is a 3-axle truck. What I mean is single axle at this point and the tandem axle. This is what we call tandem. As soon as one tire is there, then there is another tire. So there are two axles located together in the close proximity, and this is what we call a tandem axle. It's a 3-axle, but it says tandem because the drive axle is tandem. Again, the weight, allowable weight is 27.5 tons. Now there is another type of vehicle that is also a three-axle vehicle, but this is now what we call a single axle truck. Actually, this this type of vehicle we commonly known as a trailer vehicle. So is uh, this this is a steering axle, and then there is a trailer axle. There is no drive axle here. But if you can see in this vehicle, there is a single axle at the steering side, then there is a drive axle, and then there is a tandem axle. Then there's four single axle with a tandem axle. Steering axle is a single axle, drive axle is a single axle, and the trailer axle is a tandem axle. Allowable load on four axle vehicle is 39.5 tons, 39.5 tons, as being regulated by National Highway Authority of Pakistan. Then there are trailers, there are two trailers attached to it. This is called single axle. This is also called single axle, and then there is attachment that has got single axle on each of such side. Four single axle. Now this type is actually, you can see, owned by NLC of Pakistan. We will always see these type of trucks on Pakistan highways having a name NLC, National Logistics Cell. Then there are five axle, and there is a tridem axle. Single axle here, single axle here, and three axles together. This is what we call a tridem axle vehicle. Then there is what vehicle called single axle, tandem, and tandem axle. Again, there are five axle: 1, 2, 3, 4, 5. Then there is five axle single tandem. One single, and then tandem. Then there is five tandem axle, five axle tandem, single. Five axle tandem means tandem is the drive axle, and then there is a single axle, and there is a single axle. So there is 1, 2, 3, 4, and 5, and there is a single axle, 6 axle. Then this is called single, tandem, and then this is tridem axle. So on and so forth. Now, how weight are distributed on this trucks? If it is a two-axle truck, front axle carries 31%, and the rear axle is called 69%. Take 69%, and the load generally is, if the vehicle is empty, there is a 7-ton load, and if the vehicle is full, the average load is 16 tons. Now, this is estimated by a study conducted on the roads of Pakistan by National Transport Research Center. National Transport Research Center, and this is the factors we used while calculating the load on each axle. There is a code associated to this type of vehicle as well. It's a code we say there is a one wheel on the one wheel on the front axle, and there are two wheels on each side of the rear axle or a drive axle. That's why we call 31% and 69% on the rear one. Now, if it is a 3-axle single, means each of them are 3 single axle. The first one the steering axle will take 21% of a load, drive axle will take 40% of a load, and steering and the trailer axle will get a 39%. This dash denotes that this is a trailer unit truck. The load generally is 12 ton and the average load found on Pakistan is 32 tons. Then there is a 3-axle tandem. Now it's a single unit truck in which the front has got single axle and there is a tandem axle. So there is 21%, and when we calculate the load, we combine these two load percentage on these two axles together. So on the front there is a 21% of load, and there is on the rear there is 79% load because tandem axles are located together. Then there is a 4-axle rear tandem, front 14%, middle or drive 30%, and the rest 56%. Maximum load is 40 tons. Then there is a 5-axle tandem truck. 12%. On the drive, this is tandem axle, so we'll add those of them. This will become 40%, and then the rest 48%, rest on the trailer axle. So 23% empty load, 23 ton empty load, and 47 ton. Last but not least is a tandem trident, 11%, 33%, 54%. There is an error of 2%, but since these loads were rounded to whole number, that's where the error comes from. So you need to ignore that error. What you can do is say 11%, 33%, and the rest we take on this trident axle load. Generally, we have maximum of 59 tons load carried by 6-axle tandem trident vehicle. Now, how to calculate load on each axle? For instance, this is a 6-axle vehicle. So, if it carries a 47-ton load, 11% will come here, means 11% of 47. 33%, as I've said, 16 plus 17, 33% of 47 will come here, and the rest will come here. So 47 ton is divided with this vehicle, that this portion will carry 4.5 ton, this will carry 15.5 ton, and the rest will be carried by this 3-axle or what we call a trident axle. Now, how to input traffic in H2? So we always calculate equivalent axle load factor, E equivalent axle load factor in H2. And it depends upon the type of pavement, whether it's a flexible pavement and it's a rigid pavement. What are the type of axle, single axle, tandem axle, and trident axle? What are the load on each axle, as we have calculated previously? And there is thickness or structural capacity, number as 1 to 6, and it we will discuss in the lectures to follow. And there is a terminal condition or criteria for failure, PSI, that we already have discussed in the Previous lecture, remember we said we can take terminal serviceability as 2, 2.5 or 3 depending on the classification of the road. Now, this axial load factor are also known as load equivalency factor. Remember, H2 consider traffic in terms of equivalent single axle load of 18 kPa. So whatever is the load on axle, and irrespective of axle, we always convert to that the load of standard 18 clip single axle load. What we do, we divide the given load, that is, for instance, that 4.5 ton should be divided by 18 and we raise to power 4.5. Now, for tandem axle, first we'll divide it by allowable 32 kip load. This is the load that is allowed on a tandem axle load. Maximum load that is allowed by 32 kip axle load by H2. So we divide the given tandem axle load by 32 raised to power 4.5 and then multiply it by 0.857. So what we have done here is we have converted the equivalent tandem axle load to an equivalent single axle load by multiplying by 0.857. This is required by H2 method. Now for tridem axle, the standard load allowed is 48 kip. So what we do is we divide the given load by 48 raised to power 4.5 and then multiply by 1.033 so that this could be converted to equivalent single axle load of 18 kip as required by H2 method. Now take this example. We have done this calculation before. Now, first, what we have done in the previous example, we have calculated the load in tons, but since the H2 required the load in kips, so we will convert each of these tons into kips. So if it is a load is 4.5, we multiply by 2.2205 to convert ton to kip and then it becomes 8.8 kips. And likewise, we have converted the load of tandem axle and load of tridem axle because we want to convert it in terms of kips. Now, how to calculate load equivalence factor? It's very simple. 8.882 divided by 18, 4.5, and we did not need to multiply by any factor because it is already a single axle. Now for tandem axle, we divide the given load by 32 raised to power 4.5 and this 0.857 will convert this equivalent tandem axle load to single axle load and this is what we get. Similarly for tridem axle load. I hope you have understood it very clearly how to convert a single axle load to a tandem axle load to a single axle load and then tridem axle load to single axle load and how to calculate load equivalence factor. Now we move ahead. Now once you have calculated LEF, then you have to calculate E cells equivalent single axle load, and we say E cells because this is the plural word. Equivalent single axle load of 18 kilopounds. What you do? First, you count the number of vehicle, average number of vehicle, category wise. This is what we call estimate ADT. Then we calculate load on each axle using NTRC factor, that is for 11% and 33% and 54% on each type of axle. We determine the load equivalence factor that we have done previously in the slide. Then for each truck, we add LEF to get a truck factor. And this is also known as a damage factor. A damage applied by loaded truck to a road combinedly through all its axle factor. Once you do it, then to get this is now you multiply this truck factor with ADT, so we'll get E cells per day per vehicle, and then to calculate E cells for 10 years period or any design life, we need what we do. We take ADT of the base year, there is a truck factor, then there is G into Y, this is known as projection factor. I will tell you how we discuss it, how we calculate it. Then the direction distribution, lane distribution, and multiply by 365, because this is a single day traffic, we have to convert it to a lane traffic. So this is the explanation of the equation. In order to calculate GY, we use this equation: 1 minus R power Y minus 1 on R. R is the growth rate. What is a growth rate? You know, every vehicle will be more on the next year as compared to this year. As the business grows, people buy more truck, more vehicle on the road, and that's why what we call the growth rate. In Pakistan, this growth rate is normally around 4.25. And then Y is the number of years for which roadway is to be signed. Remember, this projection factor is only valid when an R is greater than 0. And if R is not greater, if R is 0, then this equation could not be applied. So the question is, do vehicle have a 0% growth? Yes. If the model of one type of truck get old, people don't buy that truck. So on the following years, the vehicle may be decreasing but may not be increasing. And this is because of the technology. Then we must know what is the percentage of traffic in design direction. Actually, we calculate the whole traffic and they divide by direction wise. One going to north, the other coming from the north. So this is called direction, design direction. And then for pavement, we always design the lane that is being occupied by the truck. So what we say, percentage of traffic in design lane, and here the traffic means the vehicle that have more than 6 wheels. So what are the standard values of this direction lane distribution? Direction distribution is 0.55. Now, if you have 2 lanes, one in each in opposite direction, then this lane distribution is 1. You have 4 lanes, means 2 lanes each on the other direction. 2 lanes going to the north, 2 lanes coming from north, then it's 0.9. Then there is a 6-lane road, we say 3 on one each side, this factor is 0.6. And irrespective of how many lanes, if there are more than 4 lanes, if it is a 8-lane road or 10-lane road, 12-lane road, then it is 0.5. Now, we will discuss how to calculate ESLs. Equivalent single axle load of 18 kilo-pound. So, if the ADT, average annual daily traffic, of a vehicle is as follows, calculate ESLs for design life of 15 years for two-lane highway. The traffic on this type is road is a truck, there is a tankers and there is a trailer. This is a two single axle truck. This is a single axle tandem axle truck. This is a single and tandem. Students do confuse with word two. But if two is single, then it is also a single axle. But if two is together, then this is a tandem. So if I ask you what is how many number of axle here, there are two axle, one and one. Here there is three axle. These are two axle and this one axle. And this truck has got 1, 2, 3 and 4 axle truck. Average annual daily traffic was estimated as 76, 60 and 50. The growth rate 4, 5 and 6 respectively. This is very simple. Normally you don't have more than 4%, 4.25%. That's it on our routes. Now there are few steps. First, from NTR's factor, you summarize the axle load time. Again, I've given this because I want that this concept should be clear. Single, 7, 16 tons. And this I've taken from this NTR table that I've shown earlier in this lecture. There is the single and tandem, 11% empty, 32. Trailers, single, tandem, 1740. What is the concept of an empty vehicle? You say, for example, if you are constructing your house and you have asked for 200 bags of cement, the truck will be loaded on this type of truck will be loaded, and maybe for 200 bag it has got 16 tons of a load. It will come to your site, it will unload it, and now it will go back to its factory or any other place where it stands. So when the truck was coming, it was full, so where it's 16 tons of the load. But you cannot ignore this 7 tons. That's why we also want to know how many vehicles, how many times the trucks ran empty. Remember, whenever the truck passes on the road, it applies some damages. And that is that this damaging is actually the load equivalence factor we are calculating. Then, so is with this. A water tanker comes full, it goes empty. And so are trailers. That's why we also consider empty and full. And the research says that 20% of the traffic, the ADT should be considered as empty and 80% is full. And this is applied when you don't have actual data. Sometimes you have an actual data, then you always can understand how many trucks were empty and how many trucks were full. Now, now we calculate the load on each axle for empty and loaded condition. 31% of 7 tons, and this factor is to convert tons into kilopounds. So that's how 69% 7, 2.22 kilograms, tons to kips. So this is on the empty sides, and then this truck on the fuller side. 31% of 16, again this is on 2.24. And for 1.22 truck, I said 11% load goes on first single steering axle, the rest goes on the drive axle, that's why it's 79%. And the trailer axle, single, 14%, 30%, and the rest 56% on the trailer axle. This is how the loads are calculated, as we know. So if I add this become 4.82 on the front axle, 10.72 on the drive axle for unloaded condition, and 11 and 24.5. These are just the numbers that I have calculated from the previous step. Now what you do is to calculate load equivalence factor. As I've said, 4.82 divided by 18, 4.5. 10.72 divided by 18, 4.5, because both of them are single axle. This is empty condition, this is a loaded condition. Then here the first one is single axle, you divide it by 18, but the second one is a tandem axle, so you divide this value with 32 and multiply by 0.857 to make it single axle, because Ashton required only single axle load. So hence and so forth. And this is same for this type. This is single axle divided by 18. The middle one is single axle divided by 18. The rare one, the last one is a tandem axle divided by 32 multiplied by 0.857, both on empty condition and the full condition. Now we calculate torque factor. Means we add all the factor, load on each axle, the steering axle, and then if we add these two values, this is the torque factor for 1.2 on empty condition, and if I add these two values, this becomes torque factor for loaded condition. We add these two values, you will get this value. We'll add these two values, get this value. This is torque factor, and then to add these three values to get torque factor for this 4 axle truck. Now you have to know how many of them are loaded and unloaded. So we say 20%, 80% were loaded and the rest were unloaded condition. So that's why 76 we divide it, multiply by 80%, we get 61, 15, and similarly for both of 48 and 12, and then 40 and 10%. Now we calculate projection factor. So for a growth rate of 4%, we'll use this formula. 1 plus 4% means 4 upon 100, like here. The design life we were required of 15, so n is 15 here, so write 15 minus 1 divided by g, 4 upon 100. That's how I get 20. And for 5%, again same, 1 plus 5 upon 100 upon 15 minus 1 upon 0.05 or 5 upon 100. That is how I get this projection factor G into Y, as we have discussed in the previous slide. Now, what we do in this step, we will get E cells in empty condition and we'll get E cells in loaded condition. So we multiply 15, this is torque factor, that is 0.007974 into G, that is 20, and then 15, and multiply by 365. Remember, this is a daily traffic and we have to convert into yearly traffic. That's why we multiply by 365. So we do it for unloaded vehicles and we do it for loaded vehicles. So 4.121 multiply by 20 multiply by 61 multiply by 365. Now if you accumulate them, it becomes 10 million single axle load equivalent to 80 kgs. But remember, this is a whole load on a 4-lane, on a 2-lane facility. So we have to multiply it by DD and DL. As discussed, DD is 0.55 and DL is 1.0. So we have 5.672 million 18 kg equivalent single axle load of 18 kg per direction and per lane. This is how the traffic is calculated. Dear students, you must remember that this traffic is very important to calculate traffic. While it's very important for you to know how to calculate traffic on for designing a pavement. If you don't know how to calculate the traffic, then you cannot design a pavement. Actually, the most important factor in designing a pavement is to know to calculate this traffic. So this brings to an end of lecture number 3. I hope you have fully understood and have clear concept how to calculate E-cells. Thank you very much. Allah Hafiz. Take good care of yourself.